Okay, so morning to all. I hope everybody can hear me and everybody can see me.
Yes, sir. Good morning.
And
Good
एक मिनट मैंने अपना वॉल्यूम कम किया हुआ है. हाँ, पलाश. सुनाई दे रहा है ना सबको? Everybody can hear me.
Yes, sir. Good morning, sir.
Good morning. So this is what we were doing in the last class. We have learned how to. Let's start. So I talked about exponential functions, logarithmic functions, and we talked about some notation of finding the slope of a graph, right? And I told you that d by dx you can consider just like an operator, just like the square root. So just like for the square root operator, the input is placed inside, right? I showed you इनपुट यहाँ रहता है, ऑपरेटर ऐसे रहता है, तो आउटपुट उधर निकलता है, इधर इधर लिखते हैं. In the same way, we have the d by dx operator where there is a special place to write the input, and then the operator acts on the input, and then you get the output, right? Okay. I hope this was clear to everyone. And,
Yes, sir.
Yeah, and then we discussed two rules for the operator. So if you have a number multiplied by a function, then that number simply comes out, as I have shown here. And if you have two functions which are added to each other, then you can sort of differentiate them separately. You can apply the operator d by dx onto them separately, and you can add that result. Okay. So we did a couple of questions, and now we can move ahead. Okay. So more rules. So this is rule number 3. This is called the product. Okay, this is called the product rule. And what happens in the product rule is that if you have d by dx of the product of two separate functions, then this is d by dx of fx whole multiplied by gx plus fx d by dx of dx. You know, so this is very long. इतना लंबा लिखने में हालत खराब हो जा रही है. So I go back and I remember that among the many notations of d by dx, right, we had this as well, right? So fx is x square, f dash x is 2x, right? So what I can do is this is the same as d by dx of fx. No difference at all. So some clever guy said that I don't want to write this इतना लंबा कौन लिखेगा, डैश लगा दे. So what I can do is I can say that d by dx of fx into gx will be equal to f dash x into gx plus fx into g dash x. So small now. I'll give you an example. So let's say that we are supposed to find d by dx of x squared sine x. Okay. So first of all, you must recognize that this is d by dx of x squared multiplied by sine x. So basically, this is first function of x. This is the second function of x, or vice versa. It does not matter. First and second, हम केवल यहाँ पे I'm only using it for convenience. You can take the other one as the first, and you can take the remaining one as second. Does not matter. Okay. So the product rule tells me that this must be equal to the differentiation of the first function multiplied by the second function plus the first function multiplied by differentiation of the second function. Okay. So d by dx of the first function multiplied by the second function, right, plus the first function multiplied by d by dx of the second function. And we know that d by dx of x square is 2x. So this is 2x sine x. Plus we know that d by dx of sine x is cosine x. Okay. So d by dx of x square sine x is equal to this. I hope everybody is getting this. This is where, what is going to happen is that from the simple idea of slope, which was y2 minus y1 upon x2 minus x1, we are still using that actually, but the thing goes into the background, right? For example, as a child, you learned ABCD, right? And when you came to class 10th, you were reading in English, you were reading complex stories. In ICSE, I believe you have to read Shakespeare. So the idea of learning individual alphabets, of course, goes into the background because you are looking at a word. Uh, you are looking at a big word, let's say like opportunity. Then you are not going to at this stage say कि अच्छा O P U R. You're not going to do that, right? You are just going to look at it and you know that it is the word opportunity, right? So in the same way here, we are talking about the slope. Ultimately, it is y2 minus y1 upon x2 minus x1. But the complexity of the thing has increased, and therefore y2 minus y1 upon x2 minus x1 has sort of gone into the background. But it is there. It is the same thing. Okay. So your turn to apply this now. Please write this in your copies. Just let me write the questions and then I'll zoom out and out. So find, this is the question, dy by dx if a y is equal to sin x cosine x. B, y is equal to e raised to the power 3x cot x. Okay, and C, y is equal to x cube cosine x into ln x. Please do these three.
Sir,
Ah,
sir, can you tell sir that what is written after e raised to 3x? Sir, in the B part. No, sir, in the same slide itself.
हाँ जी.
Sir, in the same slide itself, sir, e raised to 3x उसके आगे क्या लिखा था सर समझ नहीं आ रहा था.
अच्छा, ओ सॉरी, आई थॉट तेरे को नहीं समझ में आ रहा कि e raised to power 3x क्या है. ओ सॉरी सॉरी, e raised to power 3, हाँ मेरे को भी नहीं समझ में आ रहा है. cot x.
Okay, sir.
सॉरी, थैंक यू, बिल्कुल सही. I hope this is not too small. You can zoom your screen.
सर एक्चुअली मुझे उसमें एक डाउट था सर, आप एक बार बता देंगे y इक्वल टू cos x कैसे निकालेंगे? sin x का आ गया मुझे, cos x का नहीं आया मुझे.
जैसे sin x का निकाला था एग्जैक्टली वैसे ही cos x का निकालेंगे.
फिर मतलब sin x को मैंने इक्वल टू cos x लिख दिया था तो cos 0 आ गया 1. तो
Sin,
सर cos x का माइनस sin x लिख देंगे.
नहीं तो मेरे को व्हाट्सएप पे भेजना ना, क्लास के बाद मैं बताता हूँ. श्रवणी लास्ट क्लास में नहीं थी क्या? हाँ हर्षवर्धन बिल्कुल सही है. क्यों श्रवणी लास्ट क्लास में नहीं थी?
I was there. Sir, these two rules are.
ये this was the first rule. This was the second. अभी तो बताया ना. Is it okay, Shravani?
Yes, sir.
So this is just a continuation of these two guys.
सर मैं आंसर टाइप नहीं कर पाऊंगा, बहुत मतलब सेकंड वाले का बड़ा है थोड़ा.
हाँ छोड़ देना, मैं भी निकालूंगा तो कंपेयर कर ले. हाँ भाई बिल्कुल सही. तनिष ने बिल्कुल सही किया, अर्नव ने बिल्कुल सही किया, आदित्य ने बिल्कुल सही किया, सिद्धार्थ ने बिल्कुल सही किया, सतगुरु ने बिल्कुल सही किया.
सर जो सी वाला पार्ट है,
हाँ
हेलो
हाँ
सर, उसमें हमें मतलब हमारा एक्स क्यूब इंटू कॉस एक्स इंटू एल एन एक्स मानना है हमें उसे.
हाँ.
ओके सर.
बेसिकली मैंने क्या ट्विस्ट किया है क्वेश्चन को कि उसमें तीन फंक्शंस हैं जो मल्टीप्लाइड टू ईच अदर.
ओके सर.
नाउ सेकंड टर्म थोड़ा सा गलत लिखा है. मनस्वी बिल्कुल सही है, आदित्य बिल्कुल सही है, आदित्य फर्स्ट टर्म थोड़ा गलत लिखा है. Omar, you are sort of absolutely right. Yeah. So बिल्कुल सही। अनिश, पहला टर्म थोड़ा गड़बड़ है। सतगुण पहला टर्म सही कर, नहीं सही तो है ना? सही। अच्छा। Shriharan, first term is slightly off. Remember that. Look at this guy. Look at the addition to our table of results. Right here. ये श्रेयस क्या कर रहा है? -1 कहाँ से आएगा बेटा? नहीं नहीं, गलत है। You have made one. I'll tell you what you have done, Shreyas. You have made one mistake in the sign. बस एक mistake किया और आपका आंसर बिल्कुल गलत हो। You have made a mistake in the sign of one term. That's it. बिल्कुल सही आदित्य, yes.
सर वो सी ऑप्शन दिखा सकते हैं?
Oh, very nice.
यस सर।
बहुत बढ़िया। स्मिथ बिल्कुल सही है। हाँ, लग तो रहा है ना, मेरे को सब कुछ सही लग रहा है। पहला टर्म देखना ना, थोड़ा सा गड़बड़ लग रहा है, देखना। सेकंड क्वेश्चन अर्नव का जो पहला टर्म है वो गलत लग रहा है। हाँ आदित्य, अब सही है। हाँ बिल्कुल सही। Great, good. Okay, so now let me solve it. dy by dx is equal to dy dx of sin x cosine x is equal to dy dx of sin x into cosine x plus sin x into dy dx of is equal to cosine x sin x minus is equal to cos square x minus sin square. Okay? If you want to reduce this further, right? If you want to reduce this further, then you can also equal to cosine of 2x. Okay? D y is equal to I don't need to write y because y is already written. So dy by dx is equal to d by dx of e raised to the power 3x into cot x is equal to d by dx of e raised to the power 3x cot x plus e raised to the power 3x into d by dx of is equal to 3 e raised to the power 3x, right? So this I'm getting from here, from the last one, d by dx of e raised to the power 3x plus 0 is equal to 3e raised to the power 3x plus 0. There should be no confusion about this. Okay? And I can simply use this formula, that's it, into cot x plus e raised to the power 3x into d by dx of cot x, which I have absolutely no idea. I think I've written here minus cosec square x minus cosec square. Right? Okay, please notice that I don't remember what is d by dx of cot x, nor do I want to remember. I can always go back to the table and I can look it up. That is not important. Remembering is not important. Understanding what to do is important. Understanding when to go back to that table is important. So therefore, dy by dx is equal to 3e raised to the power 3x cot x minus e raised to the power 3x cosec square x. How did minus sin x come? Like I said, I don't remember. I just look at the standard table of results. Right? So Mansi, if y is equal to cos x, then what is dy by dx? If y is equal to cos x, what is dy by dx? बताओ.
minus x.
अभी आया समझ में ना मानसे कहाँ से आ रहा है?
Yes, sir.
Sir, if we want, we can factorize it further.
Which one?
This answer, e by 3, e to the
Yes. Any algebraic simplification you want to carry out on this, please do. In fact, you will find that when the answer is given in the test, it may be a trigonometric, using trigonometric identity, somebody would have written something else. So, वो भी हो सकता है. Yes. So you can, you should. I am leaving the answer at a point where I have done the work, right? I mean, the thing that I wanted to teach you, I have done. इसके आगे जो भी algebraic या trigonometric simplification हो सकता है. For example, in the first question, for me, this is a correct answer. No problems. For me, this is also a correct answer. But when you are giving the test, you may have only this in the options. So obviously, you have to extrapolate. Simplify. Okay. Third one is dy by dx is equal to d by dx of x cubed cosine x ln x. Okay. So I think most of you have figured this out. You take this guy as 1, you take this guy as 1. So this gives you d by dx of x cubed cosine x into ln x plus x cubed cosine x into d by dx of ln x. Now this guy I know, Okay, this guy I know because this exists in my standard table of results, right? I can instantly I can go back and I can say that what is the value of here y is equal to ln x, dy by dx is equal to 1 by. I know this. But this क्या करना पड़ेगा यहाँ पे?
Sir, again, you're gonna have to use the product rule.
Yes. Apply the product rule again. That's not a problem. Okay. I'll tell you a shortcut in a moment. Apply the product rule again. I hope that you figured this out, everybody. So this would be dy dx of, so I'll put the square bracket in, plus x cube cosine x into 1 upon x. So dy dx of x cube into cosine x plus x cube into dy dx of cosine x. So this would be equal to 3x square. एक चीज मैंने मिस कर दिया यहाँ पे ln x. So this would be equal to 3x square cosine x, right? Plus x cube into minus sine x. Square brackets are still there, into ln x plus x cube into cosine x into 1 by x. Right? Now I'm not cancelling out x in the last term, and I'm not doing that for a very special reason. Okay. So look at what I'm doing now. 3x square cosine x into ln x. Right? This is the first term. I'm expanding the bracket. I'm expanding the square wala bracket. Plus x cubed minus sine x ln x plus x cubed cosine x into 1 by x. This is the answer. I hope all of you are agreeing on the fact that this is the answer. Right? Now, those of you who have not seen this before, can you spot the pattern here? Can you spot the? I have written the answer in such a way that you should be able to spot a pattern. Okay. In fact, I'll give you one more hint.
Sir, the slope of the first term into the product of the rest second terms. Then in the second term, it is the slope of the second one minus
Very
cos x.
Yes.
Then in the third term, it is the third one.
Yes. Very good. So Sharon has seen the pattern, right? I hope everybody else is seeing the pattern. The pattern is that what were we supposed to differentiate? Well, we were supposed to differentiate x cubed multiplied by cosine x multiplied by ln x. Right? Now I know that individually the differentiation of this is 3x square. I know that the differentiation of this is minus sine x. And I know that the differentiation of this is 1 by x. Okay. So when I carry out the product rule and everything, I get an answer which is 3x square into cosine x into ln x. Well, 3x square happens to be the differentiation of this into cosine x into ln x. That means that first term has been differentiated. Second and third have been left alone. Okay. Plus x cube into minus sine x into ln x. And I know that the differentiation of cosine x is minus sine x. So in the second term, the first term is left alone. Second term is differentiated. And the third term is left alone. Right? And in the then we have plus x cube cosine x into 1 by x. So in this case, what has happened? First term is left alone, second term is left alone, and the third term is differentiated, right? And I can actually write this. I hope everybody is seeing this pattern. I can write this as d by dx of f g h I dot 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 dot. क्या मतलब हुआ इसका? Anybody willing to tell me इसका क्या मतलब हुआ?
Sir, continuing.
Sir, it's going to be
There
f
can
dash
be
g h i,
Quotient,
then f g
Product of
dash h
multiple
I.
functions.
So I
It will
hope
continue to f, g, h, I, j, k till the end of the letter.
हाँ, इसका मतलब सबको समझ में आना चाहिए. इसका मतलब है कि f, so I'm not even now bothering to write bracket में x, right? I should, but I'm not even bothering to do that. So f represents a function of x, g represents another function of x, h represents another function of x, I represents another function of x, and dot 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 means that there is a whole chain of functions which are multiplied together, and this will be equal to then f dash g h I dot 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 plus f g dash h I dot 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 plus f g h dash I dot 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 plus f g h I dash, right, plus f g h I dot. I hope this is understood by everyone. तो अगर आपके पास एक ऐसा फंक्शन आया जिसमें कि 4 अलग अलग चीजें मल्टीप्लाइड हैं, तो इसका मतलब ये नहीं है कि आप उसमें प्रोडक्ट रूल लगाते जाओ दिमाग खराब करते जाओ. नहीं, अगर 4 अलग अलग चीजें मल्टीप्लाइड हैं तो आप पहले टर्म को डिफरेंशिएट करो और सेकंड, थर्ड, फोर्थ को वैसे ही लिख दो. ये पहला टर्म हो गया. प्लस सेकंड टर्म में write the first term, then you write the differentiation of the second term, then the third term, then the fourth term, plus, okay, you write the first term, you write the second term, differentiation of the third term, fourth term, plus you write the first term, second term, third term, then the differentiation of the fourth term. That's it. End of the story. Right? So this is the we can call it the extended product rule. By the way, homework is I want to see who does this first, right? You do this and you send me on WhatsApp without referring to the internet. Homework is prove the product rule. Okay? You don't need to prove this guy. ये वाला नहीं prove करना है. Simple वाला product rule जो ऊपर लिखा है. Prove it. See if you can. Next is number 4. We have the quotient rule. Okay. So this is dy dx of fx upon gx. Now some people simply consider it, and correctly so, as a special case of the product rule, because ultimately this is fx multiplied by gx raised to the power minus 1. Okay? But we can consider it as a separate rule, and it is very similar to the product rule, so it is not very difficult to remember also. Okay? So this is d by dx of f of x into gx minus f of x into d by dx of gx whole divided by gx whole square. Okay, I'm going to ask you to prove this as well. Don't worry if you are unable to do. I will show you the proof in the next class, right? Or simply you can, if you can't do, then you can look it up. Google it. Okay.
It's just g of x का whole square, right?
G of x whole square. So I want to write it in a smaller format. So this will be f dash x gx minus fx g dash x divided by gx whole square. Okay, please notice it is not g of x square. Arnav bilkul sahi. If we can prove the product rule, we can prove the quotient rule also. Absolutely right. In fact, if you have proved the product rule, then you have automatically proved the quotient rule. But still, try to do it yourself. Let me give you an example. D by dx of sin x upon cosine x. Now we already know the answer to this. We already know that d by dx of tan x is equal to something. D by dx of tan x equal to sec square x. Okay, so we know that d by dx of tan x is equal to sec square x. We know that the answer should come out to be sec square x. So let me try this. D by dx of sin x.
Won't that become sin x by cos x? Won't it become tan x?
वही तो मैंने अभी बोला ना. सो रहा था क्या अभी?
हम वही प्रूव करने की कोशिश कर रहे हैं.
We know the answer ना. We already know the answer. Shreyas,
Yes,
समझ रहे हैं
sir.
मेरी बात? We already know the answer, right? D by dx of tan x we already know is sec square x ना. हाँ गया, सो गया क्या फिर? हेलो श्रेयस.
नहीं सर, हूँ सर.
तो हमें पहले से मालूम है ना कि डी बाई डी एक्स ऑफ tan x sec square x होता है. तो मैं क्या कर रहा हूँ कि tan x को मैं जबरदस्ती sin x अपॉन cos x लिख के quotient rule लगा रहा हूँ to find out whether I can prove this or not, whether the quotient
Yes, sir, understood.
will work. So this will be गलत लिख दिया. So this will be sin x multiplied by d by dx of cos x whole upon cos x square. Okay, so this will be equal to cos x into cos x minus sin x to minus sin x upon cos square x is equal to cos square x plus sin square x upon cos square x, which is equal to 1 upon cos square x, which is equal to sec square x, right? Which we already knew. We already knew that is there.
Sir, this is like a way of proving for tan x now.
You can say that it is a way of proving for tan x, but I want you to, if you have not done it, I want you to prove it using the first wala principle, which is f of x plus dx minus f of x divided by dx. So tan of x plus dx minus tan of x upon dx. And then you look up the formula of tan a plus b, you apply that, and you expand, and then you do that. I mean, that is one way of doing it. This is the other way. Okay, so I want to give you a couple of questions. 100%. Find dy by dx if y is equal to tan x upon x, the y is equal to, in fact, I want y is equal to root x plus 3 upon something very simple, sin x. C, y is equal to x square cosine x divided by how to say. नहीं होगा. So generally, if you have a complicated function of x, you can be absolutely sure that the answer will not be 0 because ultimately you are finding the slope. Na? So if you right, I mean we can check. Let's check. I don't know whether I can. Half of tan x upon x. क्या आ गया? टैंक आ गया. Oh,
Sir, is it whole root x plus 3 or it is just root x plus 3 in the second part?
root x plus 3.
Okay, sir. Thank you, sir.
डेस्मोस है आपके पास उमर? डेस्मोस करके क्या आता है? मेरे पास है नहीं. DESMOS डेस्मोस में ना आप जाओ और एक बार tan x by x उसमें डालो, उसका ग्राफ आ जाएगा.
Okay, sir. Sir, could you repeat the name of that?
DESMOS डेस्मोस DESMOS. अभी नहीं करना है, क्लास के बाद करना है. पहले इसको वर्कआउट करो. हाँ छोड़ देना अर्नव, जस्ट अभी मैं करूंगा ना तो जस्ट कंपेयर इट कर देना. क्वेश्चन रूल का जनरली आंसर एक टर्म एक्स्ट्रा आ गया ना, बड़ा हो जाता है. In physics, by the way, we'll never ever be getting functions like this. Never. फिजिक्स में डिफरेंशिएट करने के लिए जो आएगा वो बहुत तगड़ा आया तो डिफरेंशिएट x² + 5x ऐसा कुछ आएगा. हाँ करेक्ट है करेक्ट है। अब इसमें गलती का स्कोप तो बहुत कम है ना, the scope of making a mistake is wrong, is very small, and the only place where it is possible is the third one, where I hope everybody has realized that in the third one it is not only the quotient rule that is being applied. In the
प्रोडक्ट
third
रूल
one,
भी हो रहा है।
the third one we are applying the product rule as well. हाँ ऋतिक, यस, डोंट वरी, आप लिख लो अपनी कॉपी में और अभी अपन कंपेयर करते हैं।
Sir, can't we do the third part just using the product rule?
Yes, you can. Like I said, the quotient rule is a special case of the product rule. So you can consider that as the product of three functions, x square cosine x into 1 upon ln x. The answer you will get will be the same. Nothing, Shriharan. That's a very good question. Shriharan is asking ln x whole square क्या होता है? Nothing. You just write it as ln x whole square. That's it. End of story.
Sir, what
सर
is the
ln x is 1 upon
differentiation?
x, right?
हाँ क्या एक एक करके
सर ln x is 1 upon x, right?
No, ln x का differentiation is 1 upon x.
अच्छा
ln
ओके
x is not 1 upon x. ln x का differentiation is 1 upon x.
ओके सर।
Sir, what will be the differentiation of 1 by ln of x?
अब वो जो नेक्स्ट रूल हम पढ़ेंगे उससे आएगा। d by dx of tan x upon x is equal to d by dx of tan x into x minus tan x d by dx of x whole divided by square, which is equal to sec square x to x minus tan x into 1 on x square. So dy by dx is equal to x sec square x minus tan x upon x square. I think most of you got this right. हाँ, good. अनिश सेकंड वाला देखना एक बार, सेकंड वाला देखना ध्यान से. So dy dx of root x plus 3 upon sin x is equal to dy dx of root x plus 3 into sin x minus root x plus 3 into dy dx of sin x whole upon sin x whole square. So dy dx of root x plus 3 is 1 by 2 root x, because plus 3 ka differentiation is 0, right? Does not have a slope, into sin x minus root x plus 3 into dy dx of sin x cosine x whole divided by sin square x. ठीक है हरीश, देखो आंसर में आपका कहाँ पे गड़बड़ हो रहा है. हाँ, do it slowly. There is no, right now when we are learning, there is no rush. See.
Sir, can you explain the second step again?
कौन सा?
So 1 by root 2 x sin x वाला second step.
हाँ, ये वाला नेक्स्ट स्टेप समझ में आ रहा है.
Okay.
देखो देखो देखो, मैं यहाँ से यहाँ आया. हाँ, कैसे आया मैं? d by dx of root x plus 3 is equal to d by dx of root x plus d by dx of 3. Will you agree with this? Bolo, will you agree with this?
Yes, sir.
हाँ, क्या सही है ना? ये सही लिखा ना मैंने? रूल नंबर 2 यूज किया है. अब आप मेरे को बताओ कि d by dx of root x क्या होता है? ये तो हम निकाल चुके हैं ना. d by dx of root x क्या होता है?
So 1 by root x.
1 by 2 root x.
1 by 2 root x.
पावर नीचे आ जाता है, शायद याद है ना?
Okay.
ये हो जाएगा 1 by 2 root x plus 0, because d by dx of 3, d by dx of a constant, d by dx of a number is 0. I think I would have written that ऊपर. तो नहीं लिखा है मैंने. इससे भी पहले लिखा क्या?
शायद आपने जो बाकी स्लोप लिखे थे उसी के साथ लिखा था.
क्या ठीक है? I mean,
सर क्योंकि y इक्वल टू 3 मतलब वो एक कांस्टेंट फंक्शन हुआ ना, तो उसका मतलब
क्या क्या? y equal to
y इक्वल टू 3 वो जो
I equal to 3 कहीं नहीं है. नहीं नहीं नहीं, don't.
हाँ वही मतलब 3 का डिफरेंशिएशन तो वो पैरेलल टू द x एक्सिस रहेगा.
हाँ हाँ, पैरेलल टू द x एक्सिस होता है ना. y is equal to constant parallel to the x axis होता है. So if I have not written this before, I think I would have mentioned it at least before. So let me just write it somewhere here. d by dx of a constant is equal to 0. Always. तो यहाँ पे मैंने क्या किया? d by dx of root x plus 3 is equal to d by dx of root x plus d by dx of 3. This becomes 0. This becomes 1 by 2 root x. ये आया समझ में अक्षर?
हाँ sir.
थर्ड वाला dy dx of x square cosine x upon ln x is equal to d by dx of x square cosine x multiplied by ln x minus x square cosine x d by dx of ln x whole divided by ln x whole square, right? Can we write 1 by 2 root x as 1 by 2 root? नहीं सिद्धार्थ थोड़ा सा गड़बड़ कर दिया ना, माइनस नहीं लेंगे ना, so let me write it here. 1 by 2 root x you can write as 1 by 2 x raised to the power minus 1, or you can write as 1 by 2 x raised to the power 1. Whenever you introduce a negative sign in the exponent, you are actually taking it from the denominator to the numerator or the other way around. And whenever you have a fraction in the exponent, that means you're talking about root. So 1 by 3 would be cube root, 1 by 4 would be fourth root. Okay? And the moment you add a negative sign, that means that you are flipping the numerator and the denominator. That means you are taking that particular exponent from the numerator to the denominator or vice versa. Okay, so that. Okay, so this would be equal to, now I have to use the product rule here, right? I have to use the product rule here. This would be equal to d by dx of x square into cosine x plus x square into d by dx of cosine x into ln x minus x square cosine x into d by dx of ln x, which is 1 whole upon ln x whole square. Now I
So
can
there x and x square will get cancelled, right?
yeah. So I will do that in the next step because I want to be clear about what I'm doing. So I get d by dx of x square as 2x into cosine x, and then I get plus x square into minus sine x whole into ln x minus x cosine x, because 1x has cancelled out, divided by ln x whole square. And now I can expand this. 2x cosine x ln x minus x square sine x ln x minus x cosine x whole divided by ln x whole square. Okay, now remember, a word of warning here. I know that this can seem lengthy algebraic expressions. They are lengthy algebraic expressions, and maybe you have not dealt with expressions like these. Maybe kya pakka, you have not dealt with expressions like these in your class 9th and 10th. But I would like to remind you of two things. Number one is that the rules that I am following, the rules of algebra that I am following, are exactly the same as you have studied in class 9th and 10th, except for the fact that now we have a new rule where we are finding d by dx of some algebraic expression. And number two is, if this seems overwhelming, then don't worry about it, because like I said, in physics, the differentiation that we are going to get would be something like x square plus 2x ka differentiation मेरे को चाहिए, right? In physics, the differentiation that we are going to see will be vastly more easy than this. Okay? And when you are in class 12, in maths, calculus is a whole chapter, right? So by the end of that, you will be better at this than I am. Okay? So you don't have to worry. You don't have to worry. Okay? Just try to absorb this new thing that that is being taught. Okay. Now we come to rule number 5.
Sir, can you scroll up?
हाँ, क्या दिखाना है उमर?
Sir, I want to see the C question first. Means it's lnx whole square. Yes, sir.
Sir, is the rule 5 chain rule?
हाँ, कहाँ पे?
Done, sir.
Where do you want to use chain rule?
नो सर, मैं पूछा था जो रूल 5 है वो वही है क्या चेन रूल?
हाँ, हाँ,
ओके सर.
हो गया उमर? Everybody, you have.
Yes, sir. Done, sir.
अगर मैं ज़्यादा फास्ट स्क्रॉल कर रहा हूँ तो प्लीज टेल मी, राइट? आई विल स्टॉप, बिकॉज मैं अपने अपने रेट से करते रहता हूँ. Normally class में when I write it on the board, then I can see now everybody writing in their copies, and then I only rub it out when everybody has written. But here the dynamics is different, so you have to tell me. And if you don't want to say anything, that's also okay. You can just write it in the chat. इसका नाम नहीं लूँगा. Okay. So rule number 5 is called the chain rule. Now there are two ways of looking at the chain rule. I will tell you both. So the first way, official way, is that dy by dx is at the end of the day just a fraction which has a numerator dy and it has a denominator dx. Right now I keep on saying that dy is a number and dx is a number, but that is not wholly true, because dy is a variable, right? It represents a very small interval on the y-axis. Dx is also a variable, represents a very small interval on the x-axis. Here, anyway. So dy by dx is a fraction, and therefore I can carry out any operation that is allowed on a fraction. Okay, and one of the most common operations that I can carry out on a fraction is that I can multiply and divide the fraction by the same number or the same expression, and it will have absolutely no effect on the fraction. So what I can do is I can write dy by dx is equal to dy by dx into dt upon dt. Right? Now, first question in your mind, t kahan se aaya? So let me answer that. T is a different variable from x and y, right? So it may have something to do with x and y, it may not have something to do with x and y. The point is that I can carry out this operation. Why can I do this? Because for any fraction I can multiply and divide. So if I have, let's say, 5 upon 4, then I can definitely multiply this by x square and divide this by x square. This will make no difference on the fraction itself. Okay. Then what I do is I rewrite this object as dy by dt into dt by dx. I can do this as well. So here I can write this as 5x square, okay, divided by x square y or x square 4 या जो भी था does not matter. So I can interchange these two because I know that multiplication is commutative, right? 5 into 4 is equal to 4 into 5. X into y is equal to y into x. Right? So dy by dx then can be written as dy by dt into dt by dx. Now you may ask, should ask, can I stop here? Can I go further? Can I not multiply by any number of variables that I want? The answer is yes, you can. Let's do that. So you can also write dy by dx as dy by dx into dt by dt ds by ds dr by dr and any number of variables that you want, and then you can interchange all the denominators and you can write this as dy by dr into
So why can only be denominators exchanged? Why can't we exchange numerators?
numerator भी exchange कर सकते हैं, no problem.
Okay, sir.
You can exchange the numerator as well. I am not doing it, but you can. So dt by ds into ds by dt into dr by dy. So that is why it is called the chain rule. That is why it is called. You can add links of the chain. Right? So we will call this link, one link of a chain. Therefore, we get many links of the chain. Okay, now of course you must ask, what is the purpose? What is the utility of this? Right? Of course, I can do this. For example, I can add and subtract the same number to any number. So 100 is equal to 100 plus 2 minus 2. But we never say that. We never आप दुकान में कुछ you go to buy something, you are not going to, or the shopkeeper is not going to tell you that look, this is costing 100 rupees plus 2 rupees minus 2 rupees. Although he would not be wrong, he would be absolutely correct, but there is no utility of saying a number like that. You can, but it is not useful. So here also this question must be raised that okay, fine, I can do this, no problems, but what is the utility of it? What is the use of it? So let me tell you the use of it. So if I get a question like find dy by dx if y is equal to sine of x square. Now this thing does not exist in our standard table of results. Y is equal to x square का differentiation that exists. Y is equal to sine x का differentiation that exists. But y is equal to sine of x square का differentiation does not exist in our standard table of results. And this cannot be solved by using the product rule or the quotient rule or any other rule that we have learned. So as of now, as of pre-chain rule, this is unsolvable. Okay. This is unsolvable. So what do? Well, I say that look, let t is equal to x square, where t is some other variable. You should be absolutely clear how and why I can do this. Okay, I can do this because this is the nature of variables. एक मिनट, just a moment. मेरे को लगा मैंने लैपटॉप को चार्जिंग में लगाया है बट नहीं लगाया है. Just a moment. So this is the nature of variables, right? I can assume, I can, and you should also be, right, comfortable with producing variables out of thin air. अच्छा, x square लिखा है, let t is equal to x square, let u is equal to x square, let r is equal to x square. You can produce variables out of thin air and assign them anything. Okay, so an unknown number will be equal to a variable, but now I'm telling you that you can take a variable and say that it is equal to some expression of another variable. Right now you may say, "अरे उसके लिए तो f of x था." So this t is something like that f of x only. Okay, but I will treat it. I can treat it as an algebraic variable, just like because ultimately x is a number, x square is a number, and therefore t is also a number.
So can't we multiply dy by dx on both sides? We will get d square y by dx.
You never multiply dy by dx. Okay. ये चीजें थोड़ा सा we must be careful about. Okay? We do not multiply. I know it looks like it. We do not multiply. Right? After all, if I do this, then you are not saying, you will never say that you have multiplied square root. है ना? ऐसा बोलेंगे क्या कभी that we have multiplied the square root on both sides? We will not say that, right? We will say that we have taken the root of both sides.
We have applied a operator.
So in the same way, we will say that we can apply d by dx on the left hand side, and therefore we have to apply d by dx on the right hand side.
So but then like you have shown us with the root, we can do double root, right? So we can apply d by dx twice.
We can, but मेरे को तो इसी का आंसर नहीं मालूम है ना. I don't know what this is. D by dx of sine of x square. I don't know what this is. Okay, now you may be thinking कि अरे ऐसा कैसे है? वो तो 2x हो जाएगा, वो तो cos x हो जाएगा. But ऐसा है नहीं, because it is the sine of x square. It is not x square multiplied by sine x. It is not sine x divided by x square. It is not x square divided by sine x. No, it is sine of x squared. Okay, and sine of x squared exists nowhere. Sine of x square exists nowhere on the standard table of results. पता नहीं कहाँ गया. अच्छा एक लेक्चर पढ़ लेता. It does not exist anywhere. It does not exist anywhere. You have y is equal to x square, right? And you have y is equal to sine x, but sine of x square is not there. This is what you have to realize, that there is world of a difference between x square, sine x, and sine of x square. Okay, so let me just rub this out, and believe me that there is no operation that you can carry out as of now that will help you with this.
So what about ax plus b?
Ax plus b?
Yes, sir, we can take a as x, then x square it will become.
A and b were numbers, right? A and b were numbers. You cannot take a and b as variables. A का मतलब है, जहाँ पे भी मैंने a use किया, right? you are of course referring to these set of equation.
Yes.
बट यहाँ पे a का मतलब होता है 2, यहाँ पे लिखा हुआ है मैंने a and b are just numbers.
But A is basically the differentiation of the inside function.
हाँ, a is
Basically the differentiation of AX plus B, right?
हाँ 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 या हाँ, अब ना थोड़ा एक स्टेप आगे बढ़ गया. यस यस, यू आर एब्सोल्युटली राइट. ये आया समझ में. a and b are numbers. You cannot take a is equal to x, you cannot take b is equal to y, you cannot take b is equal to x. a का वैल्यू एक न्यूमेरिकल वैल्यू होना चाहिए, b का वैल्यू एक न्यूमेरिकल वैल्यू होना चाहिए. Right, we have to make a differentiation between constants and variables. Constants are things which can never change, and variables are things which can always change. Right?
Yes.
Okay. So we let t is equal to x square, and then we say that look, y is equal to sine t. And now I apply d by dx on the left hand side and apply d by dx on the right hand side. And that's it. I cannot go anywhere. Left hand side becomes dy by dx. That's okay. But the right hand side is unsolvable. The right hand side is unsolvable because ये वेरिएबल और ये वेरिएबल सेम रहना चाहिए. अगर ये दोनों वेरिएबल डिफरेंट हैं तो आप इसको टच नहीं कर सकते. ओके, irrespective of what your mind may be telling you कि क्यों नहीं कर सकते हैं, ऐसा क्या है, नहीं कर सकते. Because remember that d by dx, d by dx है क्या चीज, you are trying to find the slope. So you cannot find the slope of a graph which you cannot draw. XY axis पे how can you draw y is equal to sine t? You can't, right? So what we do is we use the chain rule and we multiply and divide by dt. This is where the utility comes in. Okay, and once we multiply by and divide by dt, then we can exchange the denominators, and this will become d by dt of sine t into dt by dx. Now this thing is completely solvable. इसमें कोई प्रॉब्लम नहीं, क्योंकि जो ये वाला वेरिएबल है और ये वाला वेरिएबल अब सेम हो गए. So this will be equal to cosine t into d by dx of t, but t is equal to x square. So this would be x square. So this would be equal to cosine of t, which is x square, multiplied by d by dx of x square. So d by dx of sine of x square is equal to this quantity. Okay. Notice what I have done. I have taken this x square as t. I have assumed that look, this x square is equal to t. So what is the question? Say what is the question? What is d in dt? No, again, we have to be very clear. We have to be very clear. dt is not d multiplied by t. Okay, dt is a single object, not d multiplied by t. Whatever your mind tells you, listen to what I'm saying. This is not d multiplied by t. It is a single object. Okay? It represents a small change in the variable called t. Okay? This represents a small change in the variable called t. What is a variable called t? Well, it is a variable that I have defined. Where have I defined it? Here it is. Okay. Next question is, you can't just substitute it by dt and multiply dt by dx and differentiate x square. No, you can't. No. No. The rules are very, very rigid. The rules have to be followed. And the thing that you have to understand is that the rules of algebra are not applied here as you have read them. Okay. Algebraic rules are there, of course they are there. लेकिन यहाँ पे अगर हम it would be like this. Tan x is equal to sin x upon cos x. तो ये हमारा s और s कैंसिल हो गया, x और x कैंसिल हो गया, तो मेरे पास आ गया इन अपॉन को. This is not done. You can't do this. Not allowed. Does not make sense. It is nonsensical. लेकिन अगर हम एक बच्चे को जिसको हमने साइन कोसाइन नहीं पढ़ाया है उसको हम ये बोले हैं कि भाई हाँ ठीक है, we can, we are introducing algebra to this child and we tell that child that fine, we take variables as alphabets and if I give this equation to this child, then of course the child will, for the child it will make a lot of sense. The variable s exists in the numerator, variable s exists in the denominator, so they get cancelled out. The variable x exists in the numerator, the variable x exists in the denominator, so it gets cancelled out. Makes so much sense. But this is not done because this is not sine multiplied by x. It is sine of x. It's cos of x. Okay, so wherever the word of is used, that means you are dealing with an operator. Root of x. Okay, root of y, tan of x, d by dx of x square. Of word जहाँ पे आ जाता है वहाँ पे हम operator use करते हैं. So here, okay, here what we are doing is that we are saying that look, t is equal to x square, and then d by dx of y is equal to d by dx of sine t. D by dx of sine t cannot be carried out. Therefore, I am multiplying and dividing to this dt. Okay, what is dt? It is a small change in the variable called t. Right? And who has defined this variable called t? We have defined the variable called t. Once I multiply and divide the numerator and the denominator by dt, then I exchange the two terms in the denominator, and the expression then becomes d by dt of sine t multiplied by dt by dx, which in turn means d by dx of t. Okay? dy by dx का मतलब होता है d by dx of y. So dt by dx का मतलब होता है d by dx of t, and so on and so on. Right? तो उसके बाद से मैंने t का वैल्यू रख दिया. That's it. End of. Okay, so don't worry about this. I will start with chain rule again in the next class. Okay, I will start with chain rule again in the next class.
So it doesn't make any difference if we use the first way and the second way, right? We can use any of them.
नहीं.
So मतलब दोनों का आंसर सेम आएगा ना सर, दोनों बेस से चेन रूल के.
नहीं आना चाहिए ना, आंसर तो हमेशा सेम आएगा. तो आंसर नहीं होते. Okay. चलो. So rule number 3, 4 are absolutely clear to everyone. Product rule and the quotient rule, right? There is
Yes,
no
sir.
lagging behind there.
Yes, sir.
Okay. So I'll start with the chain rule again in the next class.
Okay, sir.
Okay, sir.
Chalo. Okay. Bye-bye.
Bye, sir. Thank you.
Bye,
Bye,
sir.
sir.
Thank you.
Thank you, sir. Bye, sir.
Thank you, sir.